All right, we're going to try a video to go over the study guide today. So hopefully this will be helpful for students as they're getting ready for the final test, studying for the final test tomorrow. Number one was prime factorization. So the way we do prime factorization, we start with 300. We break it down into two factors, any two factors. Let's say 30 times 10. And then we keep breaking it down until we get to all prime numbers. So this might be 3 times 10. This might be 2 times 5. Again, we have to keep going because this is not a prime number. So I break that down, 2 times 5, bring the 3 down, and the 2 down, and the 5 down. So the prime factorization would be 3 times 2 times 5 times 2 times 5. And we practiced writing this as exponents as well. And since there are two 2's, we could also call this 2 to the second power. And there are two 5's times 5 to the second power times 3. So this would be the prime factorization, and this would be the prime factorization using exponents. Okay, question number 3. So this is question number, question number 2 says, what number has the prime factorization 3 squared times 5 times 7 to the third power? So again, practicing with exponents, we know that 3 squared is 3 times 3, and then we do times 5, and then 7 to the third power means 7 times 7 times 7, 7 times 7 times 7, 3 sevens, 7 times 7 times 7. So to solve this, we would multiply 3 times 3 times 5 times 7 times 7 times 7. And I'm not sure what the answer to that is, so I'm going to grab my calculator. Three times 3 times 5 times 7 times 7 times 7. 15,435. So again, students are going to be able to use their calculator on this as well. The idea is, can they turn this number into this number and then multiply it out? Because that's what they need to be able to do. Question number 3 is a sort of a riddle. So what is my number? My number is a multiple of 5. So it's some number that you get by multiplying by 5 and less than 50. So somewhere in here. We also know that it's a multiple of 3. So that means it has to be a multiple of both of these. And it has exactly 8 factors. So we talked about this, and 8 factors is quite a few. So we decided that it was probably an even number. So we're going to look for an even number somewhere in here that would be a factor, multiple of 5 and 3 that would have 8 factors, maybe 30. So 30. We'll check to see if it has 8 factors. 30 is 1 times 30, 2 times 15, 3 times 10, no 4, 5 times 6. So that's 1, 2, 3, 4, 5, 6, 7, 8 factors. Yep. This strategy of finding factors we call the factor rainbow is really helpful for students who are looking to find all the factors of a number. So if you start at the outer edges and work your way to the middle, you end up with 5 times 6, and there's no numbers left in between, so you know that you've gotten all the factors. So the answer is 30. For number 4, this is one where we've been working with the distributive property and using it with rectangles. So we have this rectangle here that looks like this. And on this side is 7, and this is n, which stands for variable, a missing number. And this side is 9. And so what we've been practicing learning and talking about is this idea that 9 times this side, right, which will give us the area of this whole large rectangle, is the same as finding the area of this piece and adding it to the area of this piece. So that's basically the distributive property, and so we've been talking about how to show that. So the question says to write 2 expressions showing this. So what we would do is say, well, the first one could be 9 times n plus 7, right? Because that's how long this side is. It's n plus 7, so n plus 7. Right? That's one way of describing the area of this rectangle. Another way would be to talk about the 2 pieces and add those pieces together. So it could be 9n plus 9 times 7, right? Because 9 times n would give us the area of this piece, and 9 times 7 would give us the area of this piece, which is 63. And if I add these two pieces together, it's the same as the whole together. So again, we're not really trying to solve for the answer here. They might ask that on another question, but this one just says to write two expressions to show the area of this rectangle. So these would be the two expressions that you could write. I guess you could use capital N or a lowercase n. All right, moving on, question number 5. This is one where we've been doing some story problems where there's a cycle and the cycle repeats, and you have to find when is the next time that these numbers will line up in their cycle. So it's talking about the school cafeteria, and it says pizza is served every 6th day, so 6, 12, 18, and applesauce is every 8th day. So 8, 16, 24, keeps going like that. Suppose that pizza and applesauce are both today. How many days would they both be served again? So what we do is we find the least common multiple. We're looking for a number that these two numbers would have in common if we followed their multiples along. So if we did 6 and we kept doing 6 and 6 and 6 and 6 again, we're trying to find when that would meet 8 and 8 and 8 again. And wherever they meet, we call that the least common multiple. So 6, we would do 6 times 1 is 6, 6 times 2 is 12, 3 times 6 is 18, 4 times 6 is 24, 5 times 6 is 30, and we might need to go further, but we'll stop there. If we did 8, it would be 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. Oh, and I'm already seeing here that 24 is going to be the least common multiple. That's the first number that they both have in common as a multiple. So the least common multiple is going to be 24. That means that in 24 more days, both applesauce and pizza will be served again in 24 days. Question number 6 talks about greatest common factor. That's what number 6 is about. It says the Cassville play had a party. The drama teacher served 20 cookies, and 40 carrot sticks. And it says each cast member ate the same number of cookies and the same number of carrot sticks. Nothing was left over, and the drama teacher did not eat. So what is the greatest number of cast members that could have been at the party? So what they're thinking about here is if we were going to divide this up equally, right, so everyone got the same amount, what is the most number of people that we could divide this up by? Both numbers. So we call this the greatest common factor, the largest number that you could divide both of these numbers by. We have a lot of ways of finding it, but a common way is to talk about factors. So the factors of 20 would be 1 and 20, 2 and 10, no 3, 4 and 5, right? And then the factors of 40 would be 1 and 40, 2 and 20, no 3, 4 and 10, 5 and 8. So we look at all these factors and we say, what is the largest factor? The largest number that both of these have in common. So if I look here towards the end, I notice they both have 20 in common. So what's the greatest number of cast members that could have been at the party? 20 cast members, right? That's the largest number where everybody would get at least one cookie and at least one carrot stick. Question number B says, actually, how much did they get? Well, if there were 20 people, each would get one cookie, because there was 20 cookies, or cookie, and each person would get 2 carrot sticks. 2 carrot sticks. So that would be the answer for part B. Number 7 kind of uses the same concepts, least common multiple, greatest common factor, but doesn't require a story. It's just asking you to find them. So we have these two sets of numbers, 60 and 75, and we're trying to find both the least common multiple and the greatest common factor. So we did learn another strategy for finding these, and this is kind of a cool one, especially one like this where there's probably going to be quite a few factors and multiples that we might need to do. So instead of doing that, we use the prime factorization strategy. So the first thing we do is factorize both of these, find the prime factors. So 2 times 30, then break this down, 2 times 15, and break this down, 3 times 5. So again, practicing with that prime factorization. So we get 2 times 2 times 3 times 5. So 4 times 15 is 60. That would be right. And then for 75, I'm thinking of money, thinking of like 3/4. 3 times 25. And then 25 would be 5 times 5. So I would have 3 times 5 times 5, or sorry, 3 times 5 times 5. And that would equal 75. So to find the greatest common factor, we learned another method is to look at these prime factorizations and see what do these have in common. Well, this has a 3, and so does that one. And this is a 5, and so is that one. So it has a 3 and a 5 in common. So that means that the greatest common factor is 3 times 5, which is going to be 15. To find the least common multiple, we take that, the part they have in common, 15, and we multiply it by the rest of the numbers in the prime factorization that we haven't used. So there's a 5 and a 2 and a 2. So 15 times 2 times 2 is going to give us the least common multiple. So 15 times 2 is 30, and, oh, I'm sorry, I forgot the 5. So we have a 5 and a 2 and a 2. 15 times 2 is 30. 30 times 2 is 60. So 60 times 5 is going to be our least common multiple, and that's 300. 300. So 300 is the least common multiple. Part C says find another common multiple. So this is any other multiple. A common one that kids will find is 60 times 75. That would be a common multiple. That's always going to be a multiple of both numbers. Another one that some people do is they say, well, if 300 is in common between the two, if I multiply that by 2, make it 600, that's still going to be something that they can get to from both as well. So that's another way to look at a common multiple. So more than one right answer is possible. All right, the last page, and this page is the one that students probably might have the hardest time with, or at least have the least amount of practice with. Problem number 8 says, Dawson wrote the factorization 2 squared times 3 squared. And without finding the actual number, how can Dawson tell if the number is even or odd? Well, we did some work thinking about even and odd numbers and what happens if you add even numbers and if you add odd numbers and multiply even numbers and multiply odd numbers. And we learned that there are some certain rules. And one of the rules we learned is that if you multiply 2 even numbers, even times even, that what you get is an even number, right? So 2 times 2 is 4, 2 times 4 is 8. All of those numbers are even, so an even number times an even number is always going to be an even number. And we kind of looked at it as like this. An even number always can make a rectangle model. So like 4, 6, 8, you could always do a 2 by 4 or a 4 by 8. It's always going to be a rectangle. So if I have 2 rectangles, together they make another rectangle. So these two numbers, 2 even numbers times each other, are always going to be even. 3 squared is an odd number times an odd number. And we talked about that and said an odd number times an odd number always equals an odd number. And how that works is, if an odd number looks like this, right, like 3, it has an extra piece that's off. So that would be 2 times 3. This would be 3 times 3. And what we said is if you have 2 odd numbers, they would match up and they would make a rectangle and there would be nothing left over. So when you multiply an even number times an odd number, they match up and it turns out to be even. But when you do an odd number times an odd number like this, 3 times 3, there's always going to be one of these pieces that's extra that doesn't have a match. So that means that the answer is going to be odd. So that means 3 times 3 is going to end up being an odd number. So now I have this, 2 squared, or 2 times 2, and 3 squared, 3 times 3. This one, 2 odd numbers, is always going to be an odd number. This one, 2 even numbers, is always going to be an even number. And if we multiply an even number times an odd number, that's like 2 of these. And that means that they are going to be matched up. They are going to find a match, and that means it's going to make an even number. So I know my answer is going to be even. Right? It seems kind of complicated. We spent some time in class thinking through what it means to be an even number and an odd number and how to think about them coming together. So that's what question number 8 is about. Okay, question number 9 is using the order of operations. And we spent some time on this. You might have remembered this from school. We have a cool video that I shared with you as well. But the order of operations is PEMDAS. These are the steps. So the first step is parentheses and exponents. The next step is multiplication and division, whichever comes first from left to right. And then the last step is addition and subtraction. So number 9 gave a problem here that says 40 plus 2 to the third power divided by 4 minus 6 parentheses 2. And students had to solve this. So the first thing you would do is try parentheses. That's what the P stands for. And I look here and I see a parentheses, but there's really nothing to solve in that parentheses. So I could either skip it, or maybe you do want to get rid of it. I could change this. 6 parentheses 2 is like 6 times 2. So I'm just going to change that to 6 times 2. Take care of the parentheses. The next one is exponents, and I do see some exponents here. Exponents are those raised numbers. So 2 to the third power is 2 times 2 times 2. So it's going to be 2 times 2 times 2. That's 2 times 2 is 4, times 2 is 8. So it's going to be 8. So I could rewrite this as 40 plus 8 divided by 4 minus 6 times 2. Right? So now I've taken care of the exponents, got rid of all of them. The next step is multiplication and division, and it doesn't matter which one you do first, but we just have to do them all left to right. So if I go this way, I see here my first multiplication problem is right there, 8 divided by 4. So 8 divided by 4 is 2, so we change that to 2. So now I have 40 plus 2 minus 6 times 2. Then I keep going and I see, another multiplication problem. 6 times 2 is 12. So now I have 40 plus 2 minus 12. The last step, and I've done all of the multiplication and division. The last step is addition and subtraction. So if I look at this, that's all I have left. 40 plus 2, that's 42, minus 12. 42 minus 12 is 30. So 30 is going to be my answer here. That's the answer to number 9. So order of operations is a really important concept so students know, because if you do them in a different order, the incorrect order, you'll get a different answer. So there's only one correct answer if you do it in the correct order. The last question is asking about whether any of these expressions are equivalent to 8 times 42. So if we do and multiply that out, 8 times 42, I believe we got 336. So what we're trying to do is practice, using the different maths strategies and skills that we've worked on in this unit to decide if A, B, C, and D are or are not equivalent to 8 times 42. We may or may not need to solve it in order to figure this out. So the first one says A is 8 times 42 plus 2 in parentheses. Well, if I look at that, I know using order of operations, if I solve this, 42 plus 2, that equals 44, right? So 8 times 44, that's what this would equal. So I know if I look at this, these are not the same. 8 times 44 is not the same as 8 times 42. So at that point, that would probably be enough to show that they are not equivalent, right? They're just so different. Problem B says 8 times 40 plus 8 times 2. And so what I'm doing here is I'm using the distributive property, and I'm thinking of different ways of showing this. And if you remember back to that earlier problem, 8 times 40, we wrote it like this, plus 8 times 2 is kind of like that rectangle where these are parts of one of the sides. So another way of writing this would be 8 times 40 plus 2, right? Adding together these is the same as adding the sides together and multiplying it by 8. So this would be 8 times 42. So this one is yes. Yes, this one is no. Letter C. Letter C says 8 times 40 plus 2. So if we're using order of operations, we would multiply this first. 8 times 40, 320, plus 2 equals 322. Not the same as 336. So this would also be a no. And the last one is D. And this is 10 times 42 minus 2 times 42. And if we were going to solve this, we would use order of operations. We would use multiplication first, 10 times 42, 420. We would save the subtraction for last. 2 times 42 is 84. So we have 420 minus 84. And if we subtracted that, I'm going to do that up here. 420 minus 84. Borrow 6, 3, 336. So yes, this would be equivalent to 8 times 42. So for that one, you had to not only say yes or no, but explain or justify your reasoning. And so showing the math like this would be a fine way of justifying your reasoning. Anyway, I hope that's helpful. Also, maybe look at the last quiz that we took and some of the help that I sent at home through email, and hopefully that will help students be prepared for tomorrow's test. The test should look quite similar to our unit test. So, thank you very much. Please email me if you have any questions.